So the first thing we're going to be taking a look today is breaking down radicals. Now, we've taken a look at something similar to this earlier in the year, but it's going to become really important that we can do this now. So we're going to be solving by roots in a little bit, but this is kind of our preface to it, our beginning part of that. So I've got here for you a chart of perfect squares. We've done some of this before. Normally we don't get into these really tall ones, but we do also have them on our, might be a tan sheet, might be an ivory sheet, depending on where you're at. But here's what we're going to do. We're going to be looking, any time that we look at a radical, we're going to be looking to see if there's a way that we can find two numbers that multiply to the number underneath, but one of those two numbers has to be a perfect square. So what we're kind of outlining in my case, the purple here. So if you're not sure on something, this will be one of those places where maybe if I have a calculator, it would help me out. So the key here is going to be, we're not going to be doing decimals with these. We're going to be doing exact answers. And so to get exact answers, this is a skill we're going to have to work on getting a little bit better at. So if you need to grab a calculator, please do that. So here's how this works. First, I notice 90 is not in the list, so 90 is not a perfect square. So my job now becomes, and I'm going to make a little note of this over here, we need to get the biggest square root factor. And I'll explain what I mean by that when we get into a problem where that could be an issue. That'll probably be more of an example 2 issue. But here, when I'm looking for my two numbers that multiply to get 90, one of them has to be in the list. So like for instance, if you plugged into your calculator and you're like, I don't know what goes into 90, I'll start small like Harty normally does. Ooh, 2 and 45. Well, here's the problem. 2 and 45 aren't in the list. That's kind of wasting my time. So here's what I'd suggest doing instead. The number's going to have to be less than 90. Okay? So think for a minute, you're like, well, 81 doesn't go in there evenly. That really wouldn't make much sense at all. So try to find a number that you think would be sensible. You're like, I don't know, maybe 36 goes in. And you try something. Nope, that didn't go in even. Or maybe 16. And you'll get better at this as you do. What about 9? Ooh, 9 does. Okay. So we're going to have 9 and 10. 9 times 10 is 90. And 9 is my perfect square. So here comes the strange Harty way of thinking about things. You guys know me well enough to know at this point, I got odd ways of looking at stuff. So these two numbers are currently in radical jail. Okay? However, 9 is acting perfectly. Haha, math joke. Okay? So it's a perfect square. So it gets out of radical jail with its new identity. The numbers to the left are when I take the square root of 9, I get 3. Square root of 16 is 4, and so on. However, square root of 10 is not perfect. It is acting irrationally. Another bad math joke. So it has to stay in radical jail. That's my exact answer. Under no circumstances while we are in this section would 9.4868 blah, blah, blah be an acceptable answer. No, 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 no. We're going to do this. So we're always looking for one that's perfect and one that isn't, if it's not perfect to begin with. So I get to the next one. I'm like, all right. So I'm kind of looking at my numbers. I'm like, okay, so these are the only numbers less than 48. It's got to be one of those. Anybody got a guess on which number might go into 48? But it's got to be on the list here in my perfect squares. 12 does. Ooh, but what goes with 12? 12 and 4. 4 is in the list. Okay, so that's one option. I'm gonna get two of these next to each other. You're like, oh dear, what's Harty up to here? So 4 and 12. Okay, if I did it with, oh wait, we got another. Okay. 16 and 3 get to 48. But again, they're both in here. I'm like, what's up with that? Does it mean there's more than one answer? Not exactly. Let's take a look at this. All right, so let's look at the 4 and the 12 since we had that first. Square root of 4 is 2. Gets out of radical jail. Okay, square root of 12. We're going to come back to this in a second. I come over to my 48 here. Square root of 16 is 4. Gets out of radical jail. 3, acting irrationally. And you're like, that's weird. So I can get 2 answers. Here's where the not exactly comes in. This one is the most simplified version of what I have. Okay? We didn't do anything wrong over here, but here's what happened. If you look at 12, I'm hoping that you're going to notice something. I can divide 4 into 12. I can get another perfect square out of there. So what I'd have to do if I don't get the biggest one, because 4 times 3 is 12, is I'd have to break it down again. Square root of 4 is 2. Square root of 3, but that 2 that I had originally out there is still there. 2 times 2 is 4, square root of 3. I get the same answer, but I have a funny feeling that if some of you got to here, you'd just circle it and be content instead of looking at it and going, wait a minute, can I do it again? That's why it's so critical that I get the biggest one. Because if I get the biggest one, I'm only going to have to do it once. So when I'm trying to figure out numbers to divide in, I always start with the bigger numbers and work my way backwards. Because usually then that won't happen. She's like, but what if this is a quiz? What if this is a quiz and I put that? If this was a 2-point question, you'd get 1 out of 2. Because you did do a correct breakdown. You just didn't quite finish. Okay? This doesn't happen a lot. It does happen some, though. So I move a little further. We're doing great so far. So I get to example 3. Now, before you get cute, always look at the number underneath. If the number underneath the radical is already in the list, well, cha-ching, I'm not going to have to do much thinking here at all. The square root of 64 is 8. Just 8. Completely out of radical jail. There's nothing left in jail. This is happy, happy for everybody. So 5 times 8 is 40. That can happen, where all the radicals disappear. And then I get to this last one. Okay, this is a little of a doozy. Because you're like, Harty, there's a lot of numbers up in your chart there. The whole first column and a couple in the next. But again, let's use a little common sense. I don't think 144 or 121 is going to work. I don't think 100 is going to work. But let's try some of these other ones. But again, start with the bigger numbers and work your way down. 162 divided by 81. Sweet. Right off the bat. So 81 and 2. Because again, it's the number you divide by and what you get out for your answer. So the square root of 81 is 9. Perfect. Out of radical jail. 2, not on the list. At least not on the perfect square side. And I break that down. Okay? A major part of what we're doing in this particular section is this, is breaking down a radical. So your job will be moving ahead. Okay, because again, date this side as your notes. Okay, this is the notes side. When we flip over, this is going to be the homework side. We're breaking down radicals just like we did on the other side. Now, if you need to flip back and forth for a bit, that's okay. Or maybe what you do is you pull out your factoring help sheet and get your perfect squares rolling. So just to get started on one here, we might as well. You're like 147. I don't know what's going to go into 147. Let's see here. Let's try, I don't know, 81. Nah, that didn't work. 64, I don't think, no. Whoa. Help if I hit divide, wouldn't it? Ooh, 49 and 3. Okay, 49 and 3. 49 and 3. And I will make one other little bit of advice. If some of you are not sure which one's going to break down each time, you might want to write the perfect square or the one that you find in your list in another color, because then you'll just be like, okay, you know, the purple one's the one that breaks down. So 7, and then the 3 stays underneath. So I'm just going to practice those a bit. I'm going to play with them some, see how they're all working, and get some practice at this, okay? So that's part of what we're doing. Now the other part, or where that's going to lead us, is going to start going on the other sheet. So even though you're going to want to get on a roll, stick with me and head to the other notes as we're doing this. Don't just sit here and then go back there and go, oh, I missed the entire lesson on that. That wouldn't be too good. So, okay. The other part is where we're actually going to be solving. And I'll tell you how we're going to work this. Because this is going to be another one of those homework / note sheets. The homework is going to be numbers 10 through 20. We'll chat about the back a different time. So the homework on here is going to be 10 out of 20. So we're going to work on 1 through 9 together. And yes, I see there's 21 problems. We're just going to cross number 21 off. So when we get to dealing with these, one major rule. There are going to be 2 answers for these. And so my reminder here is going to be we need to remember what's called plus minus. And once I do a couple, you'll see exactly what I'm talking about, because that's where the whole 2 answer part is going to come in. We get our reminder. We're not doing decimals. Okay, exact answers means there's going to be radicals in most of these. Maybe not all, but most of them. So I get to the first one. We're going to solve these like we solve a regular equation. My job is to get x squared alone. Well, if it's already alone, that's even better. The opposite of taking the square of something is to square root it. Once I get to this part, now it's just like what we were doing on the other sheet, where I need to look at my perfect squares and say, hey, which one of these numbers divides evenly into 60? And so you might play with them for a bit. You kind of start to say, no, it's a decimal. Plug that in, decimal, decimal, decimal. And you finally get to 4, and that ends up going in. And so you do 60 divided by 4, and you get 15. So I break those down. Again, the perfect square is the one that gets out of radical jail. Squared and square root cancel. And here's the part again that I was talking about up above now. There's always going to be 2 answers. So you're like, wait, I only have 1. If you put plus minus in after you take your square root, that's where it comes. Positive 2 squared root of 15, negative 2 square root of 15. I got 2 answers. That's where the whole idea of 2 answers is coming from. But before I do that part, before I do the square root, I have to have x squared alone. Here, x squared is not alone yet. What's my one step to get it alone? Divide by 5. X squared equals 13. Okay, x squared's alone. Take my square root. Write down my plus minus, because I know I'm going to need it. But then we get a little different of a situation. Because this time, I look and I'm like, well, there's not many numbers here. Shoot, this isn't going to take me very long. So I get on here, 13 divided by 9, decimal. 13 divided by 4, decimal. And I'm going to be honest, I don't want to cross off the 1, but 1 isn't really going to do anything. So you're like, well, then what? In that case, if there isn't a perfect square that's a factor, you just leave the whole thing under the radical. And that's going to be the part for some of you that's going to drive you crazy at the start. You're going to be like, I'm not sure if I'm supposed to break it down or not. What do I do? What do I do? Again, if you try dividing in the numbers, except 1, we don't really want to do 1. And that's as far as you get. That's as far as you get. And that's okay. So again, first job always, try to isolate your squared term. Okay, that minus 8's in the way. I do the opposite. I get it out of there. Is x squared alone yet? Nope. So I'm not doing square root yet. I'm still working on getting x squared alone. Okay. Once x squared is by itself, then we do the square root. Then we consider, okay, 10. Well, there's not many numbers smaller than 10 either. 10 divided by 9. Nope. 10 divided by 4. Nope. Harty says 1 doesn't help me. That's as far as this is going to go. There's my plus minus. I do that the step after my square root. I leave it as 10. Because again, some of you may be like, but 2 and 5 is 10, but one of the numbers has got to be in the perfect square list for me to break it down. That's going to be our other thing. We got to kind of jump over here. Time for a little mini twist. And then we're going to, after 4, we're going to pause for a minute here and see how some things are going. Now here, oh boy. I know all sorts of fun things that can happen on this problem. Okay, first goal. Get the parentheses alone. Like, okay, how do I do that? Whatever fraction is in front, we're going to multiply both sides by the reciprocal. We're going to flip it. Because by flipping it, 3 over 1 times 1 over 3 cancels. Twelve times 3 is 36. Okay. Here's the one exception to the rule on getting x by itself first. Okay? One thing I will stress to you. Do not FOIL this. Do not distribute the squared. Do not multiply it out. Okay? If the x is stuck in the parentheses, and it is right now, the next step to get it unstuck would be to take the square root right now. Because now, that gets rid of the parentheses in my squared. I got my plus minus. Can I break down the square root of 36? Oh yeah, it's a perfect square. The square root of 36 is 6. There's no radical left this time. This is going to be weird. So I get to the end. Still want to get x by itself. So I minus 4, and we deal with our last little possible hiccup place here. So negative 4 plus or minus 6. It's not plus or minus 2 now, okay? I'm keeping them separate. And so what I can do here, since there's no radicals left, is I can separate them and say, okay, so I got negative 4 plus 6. I got negative 4 minus 6, if I just follow along. And I can actually get those two answers. Okay? Unless they break down perfectly like this, I'm not going to get down to the final end and I'm going to have a radical left. But here it worked out okay. So are we seeing any issues so far? Besides the idea of we're going to have to get some practice at breaking down radicals. Otherwise, it's Algebra 1 equation solving, and a lot of you are really, really good at that. So this should be something where we really get some good stuff going. Okay. So, when I get to number 5, because we're not going to do number 6 today, so if you need a little extra room, you can do it. Looks the same as number 4 did. You're like, okay, so, Multiply by that reciprocal. Okay, so we're going to multiply by 2 over 1. Because I want to get rid of that fraction first. And 30 times 2 is 60. Okay, so kind of using number 4 as my guide. I'm like, okay, I don't want to FOIL it. I don't want to distribute. I got to get rid of the squared next. Okay, so I'm going to do my square root. Now here's where I got to do a little bit of thinking. Square root of 60. Come back to my perfect squares. And I'm going to start trying to divide some things into 60 here. Now, there's a chance that there may not be anything that goes into 60. I'm not 100% sure. I'm hoping something's going to go in here. Whoops, what did I do? Oh dear. Aha! I made it all the way down to 4, but I found one that went in nice. So 60 is the square root of 4 and the square root of 15, of which only one of them is perfect. So only one gets out of radical jail. You're like, okay, this is getting kind of weird. Here comes the finale. I want to get x alone. Okay, I'm going to plus 5. Here's the one thing I got to watch for. Okay, this 5 doesn't have a radical with it. I can't combine these. I can't even, you're like, well, can I break it up into pieces like you did this one now and do 5 plus 2 with that and 5 minus 2? No. And here's why. Let me ask you this question. You don't need to write this down, just kind of see. If I had 5 plus 2x and 5 minus 2x. Let's pretend the radical was an x. Would that be 7x? We're like, no, this has x and this doesn't. Or would this be 3x? Well, no, this has x and this doesn't. You know, that'd be as far as I can go. Same here. If this doesn't have a radical and this does, that's as far as I can go. So in this case, that funky looking thing is the answer. So I just have to think about that a little bit. And if you need to have a notation like this over there, to just kind of remind you, oh yeah, treat that like it's a variable. Okay, I can kind of probably work that out and make this be okay. Okay, I got 2 last ones that we're going to take a peek at, and then I'm going to kind of let you loose for a little bit. So we're going to look at 7 and we're going to look at 9. So 7 gets us a little back to normalcy. Okay, there's my C term, no parentheses this time. So do my plus 35. Again, wanting to get C by itself. Again, I'm a fan of boxing in the part I'm trying to get along, so I'm like, hey, that's times 5. I got to do the opposite. Pull out my squares sheet. I'll give you the rundown here. I'll be your human calculator. 31 divided by 25, decimal. 31 divided by 16, decimal. 31 divided by 9, decimal. 31 divided by 4, decimal. Okay, that doesn't break down anymore. So square root, cancel. Plus minus goes the step after I take my square root. And since the 31 doesn't break down, that's all I can do. Last one I'm going to do up here at the top. I'm going to save those 2 either as some help for tomorrow, or maybe you just need some yourself. I don't know. Okay, ooh, there's a lot going on this time. All right. First job. Isolate the term where my x squared is. Minus 22, you got to go. Next step. get my parentheses by themselves. I'm multiplying them by 4. Notice I didn't distribute the 4. I don't want to do it. I'm going to divide by 4. Okay, so x squared minus 6 equals 43. I tell everybody else to use the calculator, and then I don't do it. 43, okay. But notice when I got rid of the 4, now I don't have to worry about the parentheses. So now I can just do my opposite of minusing 6. And now that I'm finally to x squared, now I can take my square root, and I am happy to announce 49, ladies and gentlemen, a perfect square, plus or minus 7. Now, if the square root of 7, okay, when you take the square root of something, again, it gets out of radical jail. So get it on out of there. So your job on this sheet, okay, again, is down here at the bottom, okay, 10 through 20, similar to the problems we just did. We're not doing 21. But the other ones just get you a little bit of practice. And then like we normally do, tomorrow we'll get a worksheet. We'll do a couple on there. And then we'll get a lot of work time to be able to ask questions, check answers, of which I need to put the key out still, and get yourselves going. So take advantage here. You got about 15 minutes to play with and get that rolled.